share my screen on Zoom. Wow. Okay. I'm getting some, okay, wait, I have to go back out to give permissions. And I have to quit and reopen. So I'll be right back. Okay.
No matter how many times I've used Zoom, it always has a new surprise. Like it's never the same. It's ridiculous. It's
Okay, that's going to look great on YouTube. So I'm going to try again with the start and let John know that he can cut out the first one. Okay, are you guys seeing my screen here with the introduction to statistical learning?
Yep.
Okay, great. And welcome anyone joining on YouTube or watching later. This is the first lesson of the third cohort at the data science learning community for the run through of the introduction to statistical learning using Python. We'll be meeting every week on Wednesdays. So if you are watching on YouTube and we haven't finished the cohort and you want to join the Slack, come find us in the book club channel and you can come along. We will have a website. So this book, or like this quarto book, will get rendered up at the end. So in theory, once we complete all the notes and all the exercises, you should be able to come revisit this. You don't necessarily need to take notes while we're presenting or we're talking. It's probably better to try to be engaged, and you can get all of the stuff later. We're running a GitHub repo and everything like that. So don't worry about trying to note everything down. Each week, hopefully somebody different will present, but each week somebody will present. Generally, I'll fill in if nobody's willing to present, but there is a sign-up sheet. So let's have a quick look. Yeah, at the moment, nobody's presenting. So it would be great if you guys could. I do think from my previous experience in the book clubs that presenting is the best way to pick up the material. Kind of forces you not to be winging it, forces you to do all the stuff so that you feel prepared, which is pretty handy. I would prefer not to do it every single week. So if people could sign up, that would be great, but feel free to wait to the end of the lesson or at the end of the discussion. Each chapter will look a bit more like what the chapters are, but these chapters in this book tends to be chapter lab exercise. So presentations will be split like 1 week going through the chapter and the second week going through the exercises, unless the presenter really feels like there's not enough meat in the chapter, and then you can decide to go through the exercises at the same time. We do have our code of conduct here, so I'm not going to just read it all, but essentially, please don't bigoted language or anything that's discriminatory or just generally not being a nice person is not tolerated. And like I said, it's pretty common sense and it's pretty obvious. And I'd be really surprised if we have problems in the club, because from my experience, it's always been a really, really nice environment here. Okay, so does anybody have questions on the setup of the repo or the code of conduct or any logistical bits and bobs?
I wonder how many sessions, like how many, I think there are like maybe 6 or 7. How many of us are there? And how there's 13, or I guess there's more than 13. I'm just trying to plan how many sessions I should plan to lead. Like 2 or 3?
Yeah, let's say, I don't know if this is definitely should be the case, but what I was thinking is if you do the chapter, you might want to present the exercises anyway. Okay. So you might put yourself down on like a double like I have, but I just use
I see. Okay.
Example.
Yeah.
You can always like leave a note or a comment or like a color yourself orange, which is like maybe, which gives other people the chance. And also there's the Slack channel just to ask, like, I was thinking I'd do it this week. Does anybody else want to? Because I've already done 4 presentations. But yeah, sign up for as many or as few as you like. Not everybody has to present. I think we'll just about everybody will get a chance to, because these numbers you see there are doubles. So like we've got in theory like 26. But yeah, I'd say probably 1 to 2 weeks each, and then a few people will end up doing more.
Great.
Okay, you will notice as well, so like here, there's the DSLC break. Now that's for the like change to global, what's it called, daylight savings times, like occurs at different times in Europe and different times in the US. I think in different places and other places too, which means like people are always joining the club at the wrong hour. So a year or two ago, like they just put in this thing like for those weeks, it's not even going to bother. Great chance to like get ahead of the material, do the labs, do the exercises. The labs are kind of funny, like they're often just you're just typing like the code's already typed for you, you're just sort of entering it, it's giving some like numpy syntax or whatnot. But the exercises, they're not done for you, so you actually have to like think and answer the questions. So it is a really good idea to kind of get ahead where you can. If you're going to present, say, week 5, it's like, well, why not prepare in here so that you've got everything done and you don't have to worry. Yeah, that's the main thing. It will go back to the normal time after this week. Like I don't think there's any funniness there. Okay, so there are no more questions. I'll go through the introduction to the first chapter. Okay, so we're doing this book about statistical learning, and I thought before we do dive into the book or look at anything, it's probably good to take a step back and think about, well, what is statistics? Like, we're not necessarily here to do machine learning or to do supervised machine learning. We're here to do statistics, and we want to do statistics because we want to understand data better, and we want to understand the data better because it tells us something about the world. And it's always really good to keep that in mind when you're doing some machine learning or anything. The real idea is try to understand the world better. It's not to run a fancy algorithm. So if you can do it in a simpler way, you'll always want to. And it was a really brief kind of interlude in a really long podcast. Ilya Sutskever was talking from OpenAI. He's actually talking about language models. He's talking about next token prediction. And he's saying something along the lines of like, I'm going to challenge the claim that language models just do next token prediction. He said, they do all these other things and it's not statistics. And he's like, but it is statistics. And then he says, well, so what's statistics? And he says, like, in order to understand the statistics, the language model has to like compress them. And to do that, it has to understand what's true about the world that creates those statistics. And that's what we'll really be doing in statistical learning, is we'll be trying to get some tools to help us understand what led to the creation of the statistics that we're looking at. I think it's a really nice grounding to kind of keep that in mind. But the book, as we're following it, it does focus on 2 main types of statistical learning. I'm sure some people are familiar with both of these, but if you're not, a really high level idea for supervised is that you've got some labeled data, you want to make some predictions on that data in the future. Or you want to make some predictions on new data in the future. So you want your model to learn from your training data and like to predict things in the future. And you've got your labels, so it's kind of like a supervised situation. And then we'll also be looking at some chapters on unsupervised learning, which is where you don't have the labels, but you want to understand something about the nature of the data, like find some groups in there or cluster analysis or reduce dimensions. And they're different types of task and you use different types of algorithms, but that's kind of a nice bracket that we'll be looking at in the book. Any questions on these? And has anyone seen this podcast, by the way? Okay, yeah, I'd recommend watching this clip. I'm not going to watch it now, but it's just a 2-minute clip. Okay, we got the adverts. But it's just a 2-minute clip, and Ilya in it is just really clear on like a nice way of framing statistics. So I would recommend watching that. The prereqs, and these are just taken from the book. And this doesn't mean if you don't have these prereqs, like please don't come. It's like these are good things to have, and most of them, I think, in that break of the 3 weeks, if you hadn't got a basic understanding of some statistics previously, you could get it in those 2 or 3 weeks. But it basically says they expect that people will have done some elementary statistics. You might have a background in linear regression. It's not necessary, but it'll be useful. There's not so much maths. There's a bit of like matrix operations involved that they should be handy sometimes, because in the notation they want to just tell you like AB, like matrix multiplication. Maybe handy to be aware of that. It does get covered in the first chapter. So this is currently on a local host, because I just rendered it for the book club. But this will go on to a GitHub repo, and then you will be able to view it afterwards. But yeah, my sneaky little local host for now. They do say some programming language is, useful but not required. I think everyone here has at least dabbled with a bit of programming, but that's kind of it. Everything else they'll give us along the way. If you're feeling like any of those prereqs, something you don't have and you're worried, we'll just have a chat. We could find some resources, or we could talk about some things. I think even the matrix operations, it's not so much to pick up to get started, at least. But okay, so why this book? A lot of the people in the Slack channel come from an academic background, and this book presents itself, at least in the first chapter, as a way to go from academia into the real world, start using statistics, start deploying them in the real world, use them to find things out. And obviously the Python labs for a lot of us as either data scientists or prospective data scientists, it's really handy to add some Python to our skill set. I won't necessarily talk about this. I think this is all stuff you can find, and they're just some nice quotes, but we get some notation. So again, this is taken directly from the book. A little tip is, if say you weren't familiar with LaTeX, you could just get the code from the code tools in the Quarto. You can actually see like the raw symbols that you need to generate the LaTeX. I think for most things you'll need, you can Google how do I write this, or you can just not write it in LaTeX if you're not familiar with it, or you can just get a bit of help from ChatGPT, Claude, Gemini, or something. They're quite good at putting things into LaTeX. And I'm sorry, Tom, if it's actually LaTeX and you know this as a mathematician. But yeah, I've always heard it as LaTeX. The matrices, when they're shown, so I included this because it's a bit more complex, it's a bit more involved, but they'll use this notation for matrices and for vectors. So this is just a matrix, each rows and columns, and they'll have values in there. Some things you might find, you have functions sat in matrices and whatnot in the real world, but for now it's going to be quite simple just to think of a matrix as a spreadsheet, and you're going to have rows and columns, and we're all pretty familiar, I guess, with spreadsheets. So this is the preferred, or their notation for vectors. They could have just used square brackets and like the list type notation, or if you're programming now, you've seen vectors just everywhere because kind of everything's a vector. Just to reiterate, if you don't feel confident with LaTeX, it really doesn't matter. Don't worry about it. Ask for help if you need to, or just write in English or just in numbers. Okay, so the previous book club, they put together this slide, and they're saying they were laying things out, and they're just saying essentially this book's going to give us some tools to use to understand real world data better, to apply some theory, and teach us some algorithms, teach us some models. If I'll pause here actually just to ask, has everybody set up their environment locally so that they can get the labs and they can get the data and everything like that?
I was curious about your preference for UV over Conda, and like I know UV is like a hot new tool, but I don't really understand why it would be better. Is it just more performant, or like what's the okay?
Yeah, Conda is kind of more, I'd say, like, does it help you out more? It's kind of more opinionated. You can get into real big trouble with Conda if you're like using Anaconda, say on a Mac. I use a Mac, so I was always using Mini Conda before. Didn't love Conda. You can get some problems, like you can get problems with UV as well. But UV, just from my experience, it does a lot of caching of the packages. So if you've got them somewhere on your system and you're building an environment, like it might take 2 seconds, whereas say with pip or like Conda might have taken minutes, which is quite nice when you're building a lot of environments. There's a lot more to UV. You can do everything you kind of do with pip, and more. You can manage your Python versions easier. You can run scripts in a really nice way. Like you can run scripts with standalone dependencies, so you don't need to build the environment. You can just put a bit of code at the top that allows you to run it with certain dependencies. And just because it's in Rust, it's really fast. I think I wouldn't say like definitely start using UV. I started using it a few months ago and have just found it really nice. But I think, yeah, for most needs, and especially because I found out afterwards that this book has installation instructions with Conda from the authors. If you're not familiar with UV or you don't prefer like one way of managing over another, then I would probably recommend following the official instructions because mine will be quite loose. Another thing that I'd say is it does encourage you to work in projects. So UV is all about like same in our studio, we have these projects. UV is about creating a folder, initializing a project. It kind of forces you almost to create a virtual environment, which in Python is very handy because otherwise you can need to reinstall your whole system, which isn't that fun when it happens. But it's just a nice tool, at least I think so far. But other people,
I used it to I followed your UV instructions, so I appreciate the guidance.
okay, nice. I will say Astral, the company that do it, they do rough. It's like a it's the lint. They're making a linter, or they're making a type check for Python. They've got the linter rough, and they make really cool stuff. And they've got excellent documentation. So if you head over to Astral and like find the UV documentation, it just tells you everything you know really, really far, or most things you need to know really quickly. Yeah, you can get it like the data separately and copy it in, but you can get it from installing their package, which is really nice. We include some extra resources. So let's actually go through the repo really quickly. On John's recommendation earlier today, I forked this repo. I'm going to do a commit with a couple of nice bits like a PyProject TOML, which is like the fancy now way from UV to like manage dependencies. It's going to have a few extra things, but basically all of these Quarto documents, they are what you see along here. So you've got the introduction and each chapter. Each one has like the notes video exercises. So on your week, you'll be just editing the documents in there. All of these documents get rendered with Quarto render, and it makes the Quarto book. And it does have a few extra little bits, like down here, it has a bit about how to present, which is worth looking at before you do present. I think I'll add a couple of little bits for this with my PR, but basically it will stay the same. It will use this essential format, and yeah, it will get rendered, and then you go to here. Sorry, I've got a Zoom pop-up. Yeah, so this is not my version of the book currently, but this was the version previously. So when I PR and we merge, and then it will re-render, and each week's updates will go. I think if I remember rightly, they have notes up to week 4. So for the first 3 weeks, you can add to their notes, you can edit them, or by all means do your own because it's helpful in the process, like learning, making the slides and everything. But after that, we are on our own. So we'll be filling in this, and then future groups will get to use our slides if they want to or don't want to. I will go to the book actually, because, okay, that is not, maybe let's just go to the book website. If if you go to their resources, I noticed that they have slides, and the authors wrote these slides, and they're quite comprehensive. When I spoke to John about it, we kind of agreed they should only really be used as a crutch. If we have a quick look, they're quite in depth. They've got a lot of extra information for when they're presenting it. It's kind of hard to present other people's work. It's much nicer to present the stuff that you've created just because you know what's in there. But if you are stuck, or if you're really, really pressed for time, and you can't present, and I absolutely have to in the last minute, I'll probably lean on these. You can as well, but try to make the stuff yourself because you'll benefit from it. If you've read the first chapter, you'll be aware of the elements of statistical learning, which is quite a lot more in depth than I like the introduction. I would say on some of the algorithms and the modeling chapters, you might benefit from looking in here as well for extra information if you get stuck. But just to be aware of, that's just a slightly more like in-depth and a lot more theory to cover a lot of the stuff that we do cover. We, as you can see by the chapters also, but we'll be covering these things. So we'll be starting with, it's got traditional machine learning algorithms. We'll be working through, like in the next chapter, we'll look at linear regression, I think it is, in k-nearest neighbors. So we'll build up, and then eventually, we'll be looking at neural networks and things, which, all good fun. The book is divided into chapters. You can see we've just got the high-level overview of the chapters. I'm not going to read them out or go through them, but it's a nice little mental model of what we're going to be looking at. And they also present in the first few chapters, like, it's actually probably handier to have this, right? Because they have examples of like all of the different lots of different use cases where it might be handy to know some algorithms and be able to predict some stuff. So I'd encourage people to look through there if you're looking for more use cases, but I think they'll just occur throughout the book. There are quite a few data sets. In the first exercises, so of chapter 2, we have to get the college data set and the auto data set and do some things with it. In my little UV snippet I had, I've got them saved in here, and grab those data sets so you can read them in, you can play with them. I did have in my notes, so I use Obsidian. I did have just an example, just some screenshots that they had, which like, okay, the wages data set, that's a good one for like a regression problem because we've got a numerical output. The stock market, they present as a classification problem. We're trying to predict, does the market go up or down based on the previous days? So we've got, like, in that case, binary classification, picking between two. And it just shows you some nice EDA or some ways to think about the data and how to help you think about modeling. And there was the gene expression, which is an example of an unsupervised, like a data set for unsupervised algorithms on, where you're trying to find groups, trying to find clusters. But that is, I think that's kind of it for me for the first week. It kicks off quite a bit more next week. We get into some actual theory and we get our hands on some data. So yeah, I'll stop sharing. Any questions, any thoughts? Does anybody want to present next week?
No, but I have a question. It's just that because I look at what they were doing, basically for Python, we are not just using Python, we are using also their own package. So it's like not just using sklearn. So I don't know how interesting it is to use a package that only exists for this book. So I would like to know what is your point about that, because even to load the data is not, they have wrapped a lot of functions that we could find directly. So it means that after, should we be tied to this package or no? But it will mean to change all the lab. So I was looking at what they do, and for sure the use of the islp package change the way of coding?
Yeah, I think so. I haven't been through all of the package, right? So I can't comment exactly what's in there, but from what I understood, there are mainly utility functions that will help with a few bits specifically. They're almost like adjacent to the core point of the chapter. And in the labs, there is a lot of NumPy and pandas and scikit-learn style stuff. So you will be acquiring skills that are useful beyond just the package. When I present, if there's a lot of the islp functions, if I've got time, I probably just won't use them. And I'll be like, okay, let's do this in NumPy, or let's do this in scikit-learn or in Polars or something, just because I'd prefer to see the nuts and bolts rather than have the abstractions. But completely up to you. I think from what I understand, there'll be, yeah, it'll be more adjacent to the real tasks that they have stuff for. And you're welcome not to use it if you would prefer to skill up in NumPy and pandas and whatnot. Okay, well, yeah, I think if there are no questions, I can stop YouTube.